Let me do this slide again. So, good afternoon, everyone. Welcome to this presentation on fire risk appraisal of external walls under PAS9980 or PAS9980. It's part of a regular webinar series we run through the IFE Southern branch. So the first Wednesday of every month, we host this webinar. It's totally free to attend. We record them. Feel free to share them around after if you wish. If you go on our website, all the previous ones are on there as well. There's about 10 on there you can watch back. So I'll briefly explain, I'll briefly introduce who I am. I was looking at some of the names coming in, lots of us know each other, but for anyone that doesn't, my name is Joe. So I wear two hats. I'm lecturer in fire engineering at the University of Central Lancashire. So I specialise in delivering all of the technical modules related to industry. And I saw there's lots of students dialed in, so good to see you guys. And outside of that, I'm also director of Delta Fire Engineering and our kind of trio of companies that we have. So it's Delta Fire Engineering, Delta Fire Safety and Delta Fire Testing. I run those three firms there. So very, very busy. I do lots of lecturing, I do lots of stuff, lots of engagement like this, and I'm also a practicing engineer. So everything that I teach, I am practicing what I preach. So I work out in industry, working on external walls quite a lot at the moment through our fire safety and fire testing parts of the business. I put my email addresses on there. I'm pretty good on the emails normally. If you have questions, you want to reach out, get in touch after. The last couple of these I've done, I've ended up with lots of new connections and lots of new things going on. So it's always nice. So do jot down the email addresses and speak to me afterwards if you want to. So the aim of this seminar, so I'm going to introduce PAS9980. Now, the first thing I'm going to do is say that that's the way that I pronounce it. I call it PAS9980. I very much look forward to all the emails later of people saying it's PAS9980, it's PAS980, all these different ways of saying it. I've never found one that's correct yet, nor incorrect. So PAS9980 is what we're going to call it today. What I'm not going to do is teach us how to use it. This isn't a technical presentation that is going to, we're not all going to be able to run away after this and start doing them. It's not going to go into the methodology in a huge amount of detail. The people that this seminar is really aimed at are people that may encounter one of these fire risk assessment or appraisal of external wall forms, so they kind of understand what it is. So it's for building managers, engineers that don't work in external walls, architects, people in the industry that want to understand what this methodology is and how it's used. So we'll describe a little bit about how we use the document. I write these through the company, so we're familiar with the methodology, but as I say, it's not a training session, just an introduction, and then provide an overview of how the findings of one of these assessments might be used. So I'll start by, answering the question, what is PAS9980? So the document, as we see on screen there, it's free to obtain from the British Standards Institute. You've got to put an email in, but you get a free copy. It's a code of practice, and what it does is it gives a methodology to undertake what we call an FRAEW, a fire risk appraisal of external walls, and it applies only to existing buildings. I'll go on to talk about why that is. It is quite a comprehensive document, a couple hundred pages. I took the opportunity to read it cover to cover in putting this presentation together, which I usually do when I do these. My last presentation, or the one before, was the post-war building studies, and I read all 500 pages. So it wasn't quite as intense, this one. I took the opportunity to read it. There's loads of quite good information in there about the background and then a methodology to follow. It was sponsored by the Department for Levelling Up, Housing and Communities and the Home Office, and it came into effect on the 31st of January last year. So happy birthday, PAS9980 for yesterday. Been using it in industry for about a year. Of course, it was out for draft for comment just before that, but a year of it being really sort of stress tested out there in industry for us guys using it. In going through it, I was trying to write this slide, and I was trying to write a section about the background to it, and I couldn't do a better job than the introduction in the document itself. So this is section 0.1 of PAS9980, and it sets the precedent for why it exists as a document, and I think it does it rather well. Whenever I quote something from someone else's work, I always put it in italics, and I put in bold the point that I think is most pertinent to what we're talking about. So, of course, whenever we're talking about external walls, we all know in the back of our minds we are kind of in the shadow of the Grenfell Tower fire, and that's where this document comes from. In the background, it alludes to this. It talks about the loss of life at Grenfell Tower and the kind of prevalence of external wall work that's come off the back of that. So the loss of 72 lives in the tragic fire at Grenfell Tower on June 2017 brought the risk of fire spread over external walls into sharp focus. I'm going to skip to the bit that I put in bold. It is now known how this fire, which was unprecedented in the UK, occurred and gave rise to such a tragic outcome. Much is being done to make sure that such an event never happens again. That's the precedent behind us doing work in external walls, particularly when we're looking at existing buildings. And that's a really important point. Where we have existing buildings, where we have potential fire safety issues, particularly related to the external wall, we look for methodologies like this so we can carry out risk-based assessments. And that it's kind of, I thought it captured it rather well, where it said that much is being done to make sure that such an event never happens again. Certainly when I'm working and when I'm teaching, that's what kind of drives me on sometimes when we're doing this work. I think lots of my colleagues share that feeling as well. So it's on the basis of this that we look into these methodologies for external wall, any remediations or assessments. So any of you that have been in a lecture with me before, some of my current and former students will know that I always try to tell a bit of a story. I always try to get in some relevance to what we're going to talk about. And the way I want to do that is by talking about external walls a bit more generally, talking about the complexities. So when we write fire strategies and we look at solutions, strategies that we write, compartmentation, means of escape, firefighting intervention, all these things, we're thinking internal to the building, and we're thinking about the complexities of those individual elements. When we look at the external wall design for buildings, particularly high rise or where we've got residential occupants, there are a number of factors that can come into that external wall fire. And it's not simply a case of a material in that external wall. It's not just the orientation of one element. We need a holistic approach. We need to think about all of the components of that external wall and how they might behave together in the event of a fire. So when we look at notable fires, and actually this is a slightly longer presentation, I've taken out some slides because I'm limited for time this evening. We can look at case studies and look at some of the contributory factors. It's not always just one element that fails. It's not just the cladding or the insulation. It can be window openings, it can be cavity barriers, the specification of the materials themselves and the way they're installed. There are an awful lot of complexities to do with external walls, which is why the key word in here is the holistic approach. We have to look at lots of different things and adopt quite a lot of principles in carrying out these assessments. The fairly standard diagram that we'll be familiar with when we talk about external fire spread. There are lots of different mechanisms in which external fire spread can occur. The first one on the first bullet point, space separation, is actually not what we're talking about, but it's what I think about first of all when someone says B4, regulation B4. I think about that assessment we do for space separation, not actually what we're thinking about here. What we're trying to assess and mitigate is flame propagation. So we're looking at how a flame might spread over the external face of a building, and also if it's going to spread within a cavity, if we're going to get any secondary ignition in the external wall itself, if that's going to be able to spread to compartments beyond the compartment of fire origin. These are the mechanisms that occur in an external wall or a facade fire. So in the diagram there, we can see this actually is from PAS9980, one of the annexes. We can see that in orange, we've got a compartment of fire origin. In this diagram here, in the schematic, we've got window breakage, which we anticipate will occur. What we want to mitigate by having an external wall system designed correctly is that we don't get propagation to compartments beyond the fire of origin. We expect there may be some to the compartment directly above, but what we look to design out and we look to investigate when it occurs is a fire that's able to either self-propagate or cause secondary ignition further up or more laterally from the compartment of fire origin, and crucially, spread back into the building, in other areas, in other compartments. Of course, if we go to all the effort of having an internal compartmentation strategy, like we do in flats, we have 60-minute compartmentation between apartments, fire doors, 30 minutes, all these provisions internally. We can, it can be detrimental to that strategy if we have external fire spread. The compartmentation strategy, internal to a building, can be compromised by factors on the outside face of the building. This is a kind of entry-level fire dynamics. I do actually teach these slides on the course, on the degree. This is final year undergraduate. I usually at the beginning say where it sits. So it's about level 6, final year undergrad. Some of you guys have had these slides recently. So let's look at the legal requirements. So what are our actual requirements? And this leads us to where we might adopt this methodology in PAS9980 on a real project. So Building Amendment Regulations 2018, we recall coming in post-Grenfell, and it imposed requirements on buildings that were designed and built thereafter. So it limited the combustible nature of materials used in external walls. In 2005, though, of course, we have our Regulatory Reform Fire Safety Order. So under the Fire Safety Order, we have a requirement under Article 9 to carry out a fire risk assessment of premises. And that was amended in 2021. So the Fire Safety Act brings in or confirms that Article 9 applies to structure, external wall and flat entrance doors. So where traditionally, well, traditionally is definitely the wrong word, it's not tradition, but where historically people may not have considered parts of the building under a high-rise residential or even just a residential fire risk assessment. In 2021, we get this legal obligation. It's confirming that Article 9 applies to cladding. So we have a legal requirement to look at the cladding on the outside of a building, even if it's not cladding, just the external wall itself, when we're carrying out a fire risk assessment under the Regulatory Reform Fire Safety Order. And just to bring the presentation up to date, of course, we now have the Fire Safety England regs that came in just last week, in fact, wasn't it? 2 weeks ago. Requires a responsible person in relation to high-rise buildings to prepare a record of the design of the external wall. So there are now further requirements as well, legal duties to record external wall designs and intents for high-rise buildings. That's on the responsible person, and also to share that with their fire service in certain circumstances. I'm not actually teaching in this lecture or in this seminar the legal requirements. It's just helping us set the scene as to when we should be looking at external walls. And we now know, following the Fire Safety Act, we should be doing it whenever we're doing a fire risk assessment in residential premises. So it leads us to this idea. So how do we go about doing that? In a normal fire risk assessment, if I was doing one of a residential premises, I'd be looking at PAS99 and I'd be looking at some of the guides, the Home Office guides, and drawing on some knowledge I've got of residential buildings. But within those things, there isn't necessarily guidance surrounding external walls. So we look for a specific process, a methodology we can use. And that is the FRAEW, the Fire Risk Appraisal of External Walls. And PAS9980 was brought in to provide a methodology on which to do that. So it provides a methodology to do the risk-based review of the external walls. And perhaps that should be in bold, risk-based, because it is a risk-based approach, as is a risk assessment. It doesn't give an absolute level of safety. It's not a yes, no. It's not an absolute prediction of the way that fire may occur and grow or spread. It's a risk-based approach. So it can be used by specialists to meet the legal duty to risk assess the external walls, which we just discussed in the previous slide, is now a duty under Article 9 of the Fire Safety Order. And again, because it's italics, this is a direct quote, and I very, very much agree with this. No code of practice can ever provide guidance for all possible circumstances. There is a reliance in using any code of practice on the person that's applying it. It won't give all the answers in there. It won't cater for all different scenarios. As we've said previously, external walls particularly are very, very complex things. There's not just the specification of materials, but the way in which they're installed, the way that different areas of external walls deteriorate at different rates over time, and how that may impact the fire performance. So I put it bold, I put it on there just because I really agree with that statement, that it's not an absolute methodology you can follow, start to finish and get an answer. There is quite a lot of reliance on the person that's doing it, and we go on to discuss competence in a couple of slides' time. This is just the snippet from the Fire Safety Act that gives us, it says that a suitable and sufficient risk assessment should be made of the external walls of any building containing 2 or more sets of domestic premises. Just for reference, that one I've already discussed that. It is a pertinent point though, because the question I often get is, when is one of these assessments required? I sometimes like to look at the question differently and say, when is it not required? Let's try and define a time at which point we don't need to do it. So we know if we're carrying out a fire risk assessment, we have to consider the external walls. Now, if we look at that external wall and it is self-evident to the assessor, that fire risk assessor, that there is either no combustible material or for some other reason that dictates that the risk is sufficient, it feeds into the wider building strategy, the wider building fire risk assessment, that a more detailed analysis is not required. So if, for example, the external wall can be readily confirmed as being a traditional masonry construction, I just start getting a lot of feedback. Is somebody on there? Can someone just mute their microphone? That sounds better, actually. Thank you. So if the assessor can determine that the external wall is built of traditional masonry construction, there's nothing combustible present. If the age of the building, these come from PAS9980, but if the age of the building predates the 1960s, before the prevalence of combustible material on outside exterior walls and cladding systems, and there have been no amendments made, of course, they may make the assessment. This individual may say, we don't feel that there's a requirement for more specialist, more kind of advanced risk assessment technique of the external wall. If it can be confirmed that there are no combustible components, if there's now an M manual, there's been an assessment, there's been a previous fire engineered strategy undertaken, just reviewing the external walls. For example, a competent person has looked at some relevant test data and assessment as part of remediation or as part of a retrospective fire strategy, then there's a case to say there's no need to carry out a dedicated specific fire risk appraisal of the external wall. Under the duties of Article 9 of the Regulatory Reform Fire Safety Order, that individual may say the risk is sufficient, it it doesn't impose undue risk on the building, and that finding can just be included in the communal residential fire risk assessment. So again, in italics, we know this is a quote from PAS9980. Again, it's one that I'd rather like, and I've put something in bold. It says, it is therefore expected that the fire risk assessors will be judicious in their recommendations for an FRAEW by a specialist within the action plan of an FRA. Unnecessary recommendations for fire risk assessors would make significant demand on the scarce resources available, thereby diverting attention from buildings in which the public might be at serious risk, etc., etc. I've put a bit in bold there that we're going to come on to talk about scarce resources available. There is a very specific reason that there are scarce resources available, and I present the fact that it's because it's very difficult work to do. It requires very specialist knowledge. It brings us to the concept of competency, which is a very large section in PAS9980. It's something that I spend a lot of time teaching. So people who come and do the university course, the undergrad or postgrad, you will at some point, if you haven't already, have a lecture from me about ethics, professional ethics and competencies, and being able to identify one's own limitations and what we're good at. The undertaking of external wall fire risk appraisal of external walls, requires a lot of specialist skills, because in doing that assessment, you need knowledge of lots of different areas. So I've listed some of these out. These are some of the ones that I came up with. So knowledge of fire dynamics. I think when we're looking at this particular assessment methodology, we have to make some predictions about how a fire might spread on the outside of a building, or what the contribution of materials might be. There's some technical stuff to look into about calorific values of materials, so that there is some knowledge required of fire dynamics, but also knowledge of external wall systems design. So I think there has to be some specialization there in how an external wall is specified, how the fire strategy is written, and also the construction methods. So being able to look at something on the outside of a building and identify the type of cladding that's there, thinking about what insulation is likely to be behind there, thinking about how it's been installed. That's very, very important, an important competency for people carrying out this work. As is knowledge of fire strategies, fire strategy development and principles. A big part of doing these, and we'll come on to site-based works, but we have to identify, we have to look for instances where we have cavity barriers. Now, without a bit of knowledge about fire strategies and thinking about where internal compartmentation would be, you kind of can't target where to look for those areas, how to do your forensic investigation, your intrusive survey of the external wall. So some knowledge of fire strategy, not just for external walls, but also internal, is very important in doing this kind of work. As is knowledge of relevant regulatory frameworks. I did a very long lecture yesterday about fire safety law. I presume no one's turned up that was in that lecture yesterday. I think most of them have left the course because it was a very long lecture. But I've been looking at this quite a lot. Relevant regulatory frameworks. How important is it that we understand in professional industry what the regulatory frameworks are? I think it's very important. I teach a whole module about law for that exact purpose. Technically not a competency, but suitable insurance, although it is becoming a science in its own right. Anybody doing this has to have suitable insurance. Of course they do. They have to be competent to go to site. And if we turn up, it's not a case of turn up with a drill, take a panel off and put it back on. There should be some planning involved there, people who are suitably trained. There's a lot of health and safety risks with any site work. Quite an important one is that this isn't simply a guidance document that you can follow and gives you all the answers. It requires a lot of risk-based decision making. So knowledge of risk-based approaches. So good knowledge of PAS79, of course, helps, because that's the basis for PAS9980. But the understanding the concept of risk anyway. What's a hazard? What's the likelihood of it occurring? What's the consequence of fire spreading beyond the compartment of fire origin, for example? So a good understanding of risk-based approaches is required. Ethics. Again, some of you will be fortunate enough to have had my ethics lecture. Some of you are unfortunate enough that you've got it coming up soon. It is important, though. There are lots of ethical decisions being made with external walls at the moment. To speak candidly and to be to talk personal for a second, I know people who have bought apartments and now can't sell them. There are at the heart of this people who are in buildings that cannot sell apartments, or even more fundamentally, actually speaking to people I know who are in this situation, not only have they got a very large bill to remediate cladding, but that bill tells them that their building is unsafe, which is a much wider issue for that individual. They care little about the cost. They care far more about the fact that they don't feel safe anymore. So the ethics that we need to be taking into account here, that decisions made off the back of this external wall work has far-reaching consequences for people and society in general as well. And continuous CPD. I mean, you're all on a CPD here this afternoon. That's fantastic. I mean, we bang the drum continuously at the IFE and through various channels, the university as well. that continuous CPD is important, keeping the CPD log and making sure that we're everybody's trying to keep at the forefront of what's going on. So continuous CPD like this is very important, particularly in a field where there's lots of research going on. Now, I can talk from UCLAN's perspective. We're doing an awful lot of research into external walls at the moment. I think my colleague Eleni is on the call. She sent me a very good email this morning about some upcoming research, some PhD students we've got. So lots of good stuff going on. In an industry that has lots of research going on, we all need to keep abreast of what that is. We should be reading papers, attending conferences, attending CPDs as we're doing tonight. So back onto the competency thing, that's just a list of things that I feel are quite important for individuals working in this field. We can see that it's quite broad. It doesn't preclude disciplines outside fire engineering being involved. I actually encourage it. So I have colleagues that I work with who are architects, and we have people come and work in Delta when we're doing this sort of work who are facade engineers. I think that's very important. So it doesn't preclude people outside of fire engineering and risk assessment being involved, but it also doesn't infer that fire engineers are automatically qualified. It's a specialist area. I was doing a careers talk last week to a bunch of students, and I was talking about fire engineering itself isn't necessarily, it is a career, of course, it's a very good one, but it's not the career. There are specialisms within there. I've spent the last 3 years doing loads of CFD. So that kind of became my specialism for a little while, because I teach that and lots of my research is CFD based. I've come over to this field a little bit and find myself specialising in it. So as a fire engineer, having completed a degree and got some qualifications and letters after your name, it doesn't necessarily mean that those persons are automatically qualified. It doesn't mean we have to be a fire engineer to do this work. There's lots of things to be involved in competency, and actually collaborative approach is very, very useful in this sort of work. Again, something in italics that I've put there, so direct quote, it's recognised that the fire risk appraisal of external wall to which this PAS refers is not necessarily within the competence of a typical fire risk assessor who carries out typical FRA for a block of flats. It recommends a specialist come in and do this sort of work, or somebody that is upskilled sufficiently to be able to work in this arena. It is in some cases, not always, but in some cases, a lot more technical than a fire risk assessment of a typical residential block of flats. So an area just in PAS9980, I'll keep referring back and forth to the document, and we'll get to the methodology and things in just a second. But Annex H, I think, has quite a good section that describes this probably far better than I just have, about the expected skill sets of people involved in external wall assessment. So it breaks it down into 3 sections of roles, deliverables that we might have during one of these PAS9980 assessments, a fire risk appraisal of external wall. First of all, the information gathering. So that could be the individuals going to site to look at the existing construction. It could be reviewing the fire strategy and the drawings and the test data. It suggests for that individual they should be, individuals, they should be surveyors or building professionals such as an architect or facade engineer. PAS9980 has 2 different types of assessment, the basic level and the in-depth. We'll talk about those in a moment. But for the basic level assessment, it recommends we've got fully qualified member of a relevant professional body. And for the in-depth technical, the fire engineering assessment, a chartered engineer. And when you look through Annex H, which I encourage people to do, it gives the typical professional recognition and the skill set as well. So the example on screen there for the information gathering and site survey, able to undertake document study, conduct on-site verification, has knowledge of materials, components and systems used in external wall construction. Yeah, I certainly agree with all of those. It gives the expected skill set for anybody involved in the different stages, because perhaps we've got different people doing different roles within this. We may get to a stage where we've got somebody out on site doing the information gathering. We've got a building surveyor. We've got somebody who's involved in architecture or facades. That information goes to fire risk assessors or fire engineers to do the basic level assessment, and it's determined that more work is needed. So the in-depth work comes in. So a specialist fire engineer that works only in this field. So at different stages in the assessment, we might have different people get involved who have a requirement for different skill sets, different competencies. So the objective of PAS9980 then, we've kind of painted the picture there of why it is that we're looking at external walls specifically on the basis of some issues that are involved in fires that have occurred and historic issues uncovered as part of that investigation. There is a requirement now, a legal requirement, to look at the external wall, do an appraisal of the external wall system as part of a fire risk assessment. It's been confirmed that that is a requirement of Article 9 of the Fire Safety Order. And we know that it's very specialist. It's very difficult to do that. So PAS9980 introduced as an opportunity, a way of giving a methodology to follow, to provide competent fire engineers. This should be in italics, actually. because it's a direct quote, competent fire engineers and other competent building professionals with a methodology for appraising and assessing the scope and risk from scope 4 and risk from fire spread via external wall construction and cladding. And it's such that the outcome can be used to inform a building's fire risk assessment. Back to that idea of holistic. This will feed into the overall fire risk appraisal for the building that's occurring. So a while ago, I wrote a paper called Does Size Really Matter? And it compared the risk in buildings of different heights. Don't let the terrible pun throw you off. It was a detailed piece of work, and it was talking about threshold heights in buildings. It's kicking around somewhere. Somebody sent it to me recently. It was published in a journal somewhere, I can't remember now. And in the paper, I discussed the idea that risk isn't necessarily directly proportionate to the height of the building. Presented in there that if we consider the risk in a 2-story dementia care home, would we argue that the risk in a 3-story student residential is higher? And then we get into defining risk and talking about, if we consider the occupants, it's not necessarily just the height of the building. Now, of course, there are increased risks, consequences and severity and likelihood of an increased high-rise building, but it's not the only factor. In actual fact, we can have really high-risk premises that are on the ground floor. We could have a ground floor hospital, and the risk to the occupants is greater than somebody who is on, arguably, it's the case I make in the paper, the 10th floor of a high-rise residential building that's sprinklered and has all sorts of things in place. So does size really matter? Well, not when we're adopting this methodology. PAS9980 isn't one of these guidance documents that says it applies only above a certain threshold. It can be applied to a building of any height. It's very explicit in the introduction for that, because if we're doing a fire risk assessment, we could be looking at a building that has 2 or more dwellings. It could be 2-story, 3 stories, and we would still be obliged to carry out a review of the external wall system. So it's an important point to note, and something that people often say. I've never reviewed this document, Joe, because I don't work on high rise. I don't work above 18 meters, something like that. It's still a methodology that could be useful when we're just looking at fire risk appraisal of external walls of any height. So another important point that I've got in bold there is that it's concerned with life safety only. And again, very explicit in the document, something that we should be aware of. If we are carrying out an appraisal of the external wall, and we are looking at using this methodology, we're carrying out any assessment, we are only looking at the life safety of the occupants. It's not intended for property protection, much like if we follow the minimum requirements of the building regulations and we follow the minimum guidance of something like approved document B, we're designing for life safety only. That's really explicit in ADB and the building regulations. Any enhancement above that for property protection will further enhance the life safety, you could infer, but if we do the minimum assessment, we're only concerned with life safety, and quite right too. That should be our primary focus when we're looking at this. Go back to my very first slide. The purpose of doing this work is to prevent a fire like the one we had in 2017 occurring again. So we are looking at the safety of the occupants of the building, not necessarily the structure and the insurer's requirements, for example. Again, the methodology can be used to a building, applied to a building of any height. And the kind of purpose, the intention of the PAS9980 assessment is to inform the overall building fire risk assessment and to help make a decision on whether remediation or other mitigation measures are necessary. This is, if you Google PAS9980 and you get the automatic things from Google, it gives the most search questions. The most search question is not how do you pronounce PAS9980, it's does it replace EWS1? And I've been asked this an awful lot. So if I've got to be commercial for a moment, a fee proposal out with the client for an EWS1 form, more times than I've cared to count, but certainly half a dozen, they phoned me and said, do we not need that anymore? Do we now need this instead? Is this a replacement? And the answer is no. The EWS1 form is produced by RICS and is a valuation tool used for mortgage for lenders. PAS9980 doesn't replace that in any way. Certainly doing EWS1 forms prior to PAS9980 coming out, there was always a requirement, or at least I see it as a requirement, that when signing off an EWS1 form, there should be some risk assessment behind it. There should be some way of justifying why that assessor has said it has this rating, A1, B1, whatever it might be. PAS9980 can be used, it's a suitable methodology, or it's an available methodology, should I say, in order to do that. So you can carry out a PAS9980 assessment, a fire risk appraisal of the external wall following the guidance of the PAS9980 Code of Practice. That can be the supplementary report that goes behind the EWS1 that justifies how we've made those decisions, but it's not a replacement. And it's useful to get that one in because I get asked that question quite a lot. So it can support and inform the EWS1 form decision, but it doesn't replace it. So to go on to the actual methodology, as I say, this isn't a session where we learn how to do the methodology start to finish. It's not a training session, but let's get to the point where we can go through the methodology. As proposed or as presented in PAS9980, it's a 5-step approach. So the first thing to do is a very logical one, is to confirm that the full fire risk appraisal external wall is required. It could be that as we start to look at the documents, we realise actually there has been a previous full-scale test, 8414, and a BL135 assessment has been done. That'll lead us down the route of saying we don't need to now go do intrusive works. We've had some work done previously. So once we've confirmed that we want to do an appraisal of the external wall, it's then information gathering. And certainly when I do this kind of work, as I do anything retrospective, I look to get as much information as I can. So I'm looking for drawings, as-built designs. I'm looking for the approval at the time, the fire strategy, previous fire risk assessment, any test data. So if there has been, for example, a BR135 assessment, I'd be looking to review that, gather all that information. Having got that, we start to look into what we call factors, which we'll come on to in the next slide. We're thinking about how significant these factors are in altering the risk that's within the building. We consider each of those in step 4, and then we review that final risk factor. Steps 3, 4, and 5 is what I'll do next. But the thing to bear in mind here is, first of all, we have a desktop exercise. So we first of all confirm that we're going to carry out a fire risk appraisal of the external wall. Then we gather as much information as we can. We go through that. We start to maybe draw some conclusions. That will help inform the site works that we're going to go on to do. As I mentioned earlier, cavity barriers. If we get a fire strategy for the building and we see it's cluster accommodation, and only 60 minutes is provided around a cluster, okay, then we know we don't really want to pull off a panel that is at the junction between 2 bedrooms that aren't fire rated, because we wouldn't anticipate a cavity barrier to be there. So from this, we start to form what we're going to do in stages 3, 4, and 5. So document review, I've just been through these by accident. So building plans are obviously very important. Details of the external wall system, where these are available, specification. Fire strategy for the building, one of the first things that I pick up and read if it's available to me. Any technical literature from a manufacturer, it's always helpful to have. I look for that, hopefully, in an appendix to the fire strategy. I know certainly if I'm writing fire strategy and I've got that technical data, I put it in as part of the information under the golden thread now. Fire performance of any test results. So if there has been an 8414 test or even small bench scale tests of the components, I'd be reviewing those. And the laboratory report, any classification documentation as well that's available for the system on the building. We then have to go and carry out some form of site intrusive inspection. Now, the reason for this is quite pertinent. It's because a document that we review that says this is the intended design of the building is exactly what I've just said. It's intended construction. What we have to do is do some form of validation. So go to site and confirm that what has been designed has actually been installed. I say this with caution, but because I disproportionately see buildings that have issues with them. But in the vast majority of cases where I see something on plan, I go and it's not replicated on site. As I say, I'm not saying that it's not my opinion that that's representative of every building out there. I disproportionately see a high number of buildings that have already identified issues, but it is fairly common. It's not a surprise sometimes to take a panel off and see a cavity barrier that's incorrectly fitted, or something that's not been or has been installed and has shifted over time and isn't currently aligned as it should be. So this site inspection that we carry out, we would go and carry out a review of certain sections. We're not pulling off the entire wall at this point. The photo is perhaps slightly misleading there. We're doing sample locations. The location of those depend on a number of things. The findings of the document review, the size of the building, the availability of information. If we've had no information provided to us, we may have to do a bit more intrusive works to try to work out what we've got. The fire strategy of the building, as I've said, the example actually was quite good. Cluster accommodation. If you look at just cluster accommodation, what I mean by cluster accommodation for anyone who's lost is like a student residential, where you've got a self-contained flat, but the bedrooms themselves aren't fire rated, because that cluster would evacuate together, usually have a shared kitchen, shared living room, some form of facility within the flat. If we look at that and we say, let's take off something that's between 2 bedrooms, between the window, and we don't see a cavity barrier, we wouldn't expect that in that location, in that environment. So the fire strategy of the building might dictate areas that we're going to go and look at. Site constraints. I did one not so long ago where one side of the building overlooked a river. There's no way of getting up there and doing it without getting wet. So we risk assessed and said that we could look at another area because it was we could get onto a balcony and look around kind of the corner detail. And ability to make suitable repairs. There is a point, I had a slide in here of some howlers that I've taken out of where we've, not we, as in somebody has, taken sections off, cut holes, and then made good with plywood and cardboard and all these things. So we're sensitive to this, the aesthetics of the building moving forward. We want to try and factor that into any site works that we do. So having gone and done this, we've done a document review, looked at everything we can. Having then reviewed on site the information, which is further document review, we then carry out the risk assessment. The methodology proposed in PAS9980 for carrying out a risk appraisal of external walls is to look at 3 different factors to consider, based on the information provided, the properties of the materials that are identified through that investigative research, the configuration of those materials, so how they're physically installed, the orientation and location and the scale of them, and the overall fire strategy as well. So these 3 things, there's methodologies in place to assess a number of factors of each of these. And for each of those 3 things, in fact, for all the subcomponents of those 3 factors, there are positive, negative, and neutral consequences of each of those. And this is the bulk of the actual assessment process of PAS9980. So it is a qualitative assessment. If you follow the methodology and you follow that basic approach, what you're actually doing is a risk assessment based off of this qualitative assessment. For each of those 3 groups, we are assigning positive, negative, and neutral indicators to things that we've observed on site or things we found during our literature review. We then take the cumulative effect of all of those indicators and consider whether the things that we've observed have a positive, negative, or neutral impact on fire safety of that building. So, for example, if we have a dominance of positive factors, so lots of different things, I've got some examples on the next slide to show us, lots of positive things in that building, it shifts us a little bit further towards the low risk part of the spectrum here shown. But if we have a dominance of significant negative factors, lots of things that negatively impact the way that the building has been constructed and designed, it will shift us to a higher risk. And this is qualitative, it's not quantitative. So it doesn't say that for every negative factor, you should have a corresponding positive factor. The image on the right-hand side there is from the PAS9980 section that gives this methodology. What it says is that there is a baseline. So for this particular building, there is a high risk. So it's been identified that there is ACM, as a totally random example coming from nowhere. There's ACM on the building. The design of the building would appear that to be a high risk. But the fire performance, which is the first of these things we look at, there is, in this example, a dominance of positive factors. So that shifts it slightly further towards the medium end. And then the configuration of those things, albeit, again, this example that I'm making up entirely, albeit there's some combustible material on the building, it's installed in such a way that it's encapsulated and that they're far separated. There isn't a continuous vertical line in the building. Shift it a little bit further. Again, qualitative. We're not doing anything numerical there. It's not a quantitative assessment that says, if that is the case, we can reduce the risk profile by 2. There's no quantification in this involved. And the third one, the fire strategy and the fire hazards, again, if we get a dominance of significant positive factors, we again go to the low category. And there are lots of these that are given in the annex or 3 annexes of PAS9980. So just to go over the positive, negative, neutral things again, this is the way that they're laid out. So we would say for a factor, for example, compartmentation, is the design of compartmentation positive, negative, or neutral? So materials are the first thing that we consider. That's the materials used in the external wall or on the external wall of the building. The examples given here, if we have a positive impact would be if those materials are expected to limit the scope for rapid fire spread, but we would have a negative impact if those materials would be expected to exacerbate or promote fire spread within the external wall. And neutral if those materials are just as we would expect them to be, if it meets the guidance, if there's no discernible positive or negative impact on the baseline. So the example that it gives here for materials, the materials used in an insulation product, for example, we would have a positive impact if the calorific value of the materials we've identified on site and we've investigated, if their calorific value is less than 3 megajoules per kilogram. Conversely, if we identify there are materials on the outside of the building that have a calorific value greater than 35 megajoules per kilogram, we infer that has a negative impact on the building. So from our baseline, we've identified this high calorific value, so it's shifting us more towards the higher risk. It's not a quantified way, and there are lots of these that we look at just for the materials, but we're looking at what the kind of overall cumulative effect is of the materials. The second one is the configuration. So we're looking at the way that the materials on the outside of the building are installed. Again, positive, negative, neutral. Something that we identify as positive would be materials that are not expected to limit significantly the scope for secondary fires. The example given here for positive is that if the height of the base of cladding is greater than 5 meters above street level, that's a positive indicator, because what that tells us is that we're less likely to get a car fire or bin fire or some other fire on the external of the building outside of our actual demise, spreading to a section of cladding on our building. Whereas converse to that, if we would have materials that are less than 2 meters above the street level on the outside face of the building, that would be a negative indicator. That imposes this slightly higher likelihood that we would get an external fire spreading on the outside face of the building. And if it's between 2 and 5 meters, that would be neutral under this methodology. It says the scope for fire originating externally and igniting the cladding is possible, but not likely at an early stage. So we're looking at these indicators. Again, it's not quantifying, it's not add 1, take away 2. It's just saying we've either got a positive or negative influence from that particular indicator. And then the final one is the fire strategy. So it's the kind of wider elements of the building. Again, going all the way back to what I said at the start about we are interested in life safety here. We're interested in holistically looking at the impact of an external wall system on the safety of those within the building. So we have to consider wider elements like the fire strategy for the interior. So we would have a positive factor if we had provisions significantly increase occupant safety. It would be negative if we identified things that were missing or not installed correctly on the interior of the building, a fire strategy that has omissions or significant deviations from guidance that haven't been justified. And neutral would be it meets guidance, it's what we'd expect to see, it's neither positive nor negative. And I picked this example specifically because I particularly like it, to do with compartmentation. So let's use an example of a high-rise residential building. We would expect there to be compartmentation in that building. If it's a stay-put policy, we would expect 60 minutes between flats, protected entrance hallway maybe of 30 minutes. It's not strictly compartmentation there, but we would expect there to be fire-resisting construction within the building. So if we identify that, that's not a positive impact. That's just neutral. We expect that to be there anyway. We can't use that as part of the mitigation to say the risk is reduced, because that's just an expectation that we have. The reason that I picked this particularly is because I've been generally throughout lots of projects that I've seen where I've maybe picked up from elsewhere. They've not had a fire engineer. They've said, oh, we've had some guidance, some advice, but we're not quite sure if we need a full fire strategy. I quite often see justifications from people who haven't studied fire engineering, don't work in engineering and approvals, using things that we need anyway as justification for other deviations. So saying things like, we're not going to put sprinklers in, but extra fire extinguishers, but we've got fire extinguishers and a fire alarm system. So this is quite a nice way, and it's one that I use now to teach, to talk about how we do fire engineered solutions. Some of you had a solutions lecture from me last week. I saw you coming in. If we have a deviation somewhere in a fire strategy, we need to look for mitigation that is over and above what we otherwise require. So this is a good example. Again, if we've got adequate compartmentation in line with the expectations, that's just a neutral indicator. It's not a positive, it's not over and above, it's just neutral. Whereas if we identify inadequacies, this is a really big area. So we see penetrations that aren't adequately sealed, we see fire doors that aren't operational, self-closers that don't work, doors that are not fire rated, all those kind of things would be a negative indicator. Because if we get a fire on the external of the building and it spreads beyond the compartment fire origin, we anticipate we could begin to affect communal means of escape and things like that. So again, negative indicator from a fire strategy perspective. And the outcome of the assessment, I come to kind of the end of the presentation now. What we're looking for is, of all the things that we've assessed as part of this assessment, what impact does that have on the overall fire safety from our baseline? So the baseline, again, this is the example of, again, from PAS9980, saying we have a high fire risk inferred in this example, but the fire performance that we've identified, the performance of the materials, is substantially positive. So we shift slightly away from the bottom end of the spectrum there. Again, the configuration of those things, like the example that I gave, they're encapsulated, these materials. It would be unlikely we would get a vertical line or a lateral spread of a continuous combustible material. Again, it's shifted it in this example to a medium. And everything inside the building, perhaps as enhancements, perhaps it's a mechanical system instead of a natural system that's been shown through CFD to be better than the better performing than the ADB minimum, or we've got a sprinkler system where we don't otherwise need one. Again, has shifted it to low. And that's the purpose of doing the fire risk appraisal of the external walls. It's to feed into the overall risk profiling for the building, and it's to potentially, if it goes the other way, look at remediation, saying the risk is sufficiently high that we need to do works to this building. We need to remove sections of it. We need to maybe do things internally. I've seen recently on a job I was reviewing this week, additional heat detectors in rooms that open onto areas where we have combustible materials. It was a temporary measure, but that was something that came off the back of a PAS9980 report done by another consultant. I think perfectly reasonable in that case. It was very, very good. So as it says there, conversely, it could be found that deficiencies in the document review actually means that we go up to a higher risk. So if it wasn't previously understood that the internal compartmentation was inadequate, we may actually, off the back of this assessment, find ourselves in with a lower feeling of fire safety than when we first begin the assessment. Just to briefly touch on this, and when we do this, we run this as a training course from time to time, and I teach at the university, we concentrate on this one. That is the basic assessment. It's identifying the three factors, looking at the influence of those and assigning that to the overall building. There is then the detailed fire engineering assessment. Annex G of PAS9980 presents a proposed methodology for that. In essence, that is if we've got a result where we still have high risk or we have a medium risk, or there's still something in there that's not quite quantified, we want to investigate further, we can adopt fire engineering principles. We can start looking at other things, large scale testing. We can go out and do some bench scale tests and some CFD. That's a piece of work that we're doing at the moment at UCLan. We can look at more advanced engineering methodologies. So this is my only slide on this one, unfortunately, because I'm running very low on time. But there is a methodology to do that. And that is the next logical step, having done the basic assessment and identified high risk where we need remediation or mitigating measures in the short term. So how these reports should be laid out, again, we run a training course on this from time to time. I've accidentally put one of Delta's reports in there for exemplary report. It wasn't by accident, of course. But the things that we would look for in one of these reports, it should be a fairly standard scope. It's not a tick box. It's not a this is the sections you absolutely need, but certainly the things I look for in these reports. First of all, a clear scope. Explain what the document is. So say what the scope of PAS9980 is, the scope of the fire risk appraisal of the external wall, what's trying to be achieved. The competencies of the assessor, I think it's useful to put that, particularly because as we've identified, there are stringent requirements and stringent recommendations for people doing this sort of work. Description of the building, description of the wall system, and the building fire strategy, findings of the document review are all kind of lumped in together. In that section, we're looking to justify the work that we've done and how we've determined the conclusions that we have. The fire performance of the components, all the sections that we have in the risk assessment, so the materials, the orientation of them, and the wider fire strategy, we have the risk assessment in there, what the impact might be on overall safety, and then of course any required actions, any risk assessment that we carry out, whether it's under Article 9 of the fire safety order, whether it's a risk assessment of external wall, risk assessment of RAMs for somebody climbing up a ladder. There should be some form of either proposed mitigation in there or some actions for people to carry out. So we again expect to see those in these reports. And in fact, that's the end. The only thing I want to do is draw attention to a couple of the suggested reading sections that I have. This is me being a lecturer for a moment, I think. Always send people away with some reading. There are some sections, as I say, I took the opportunity this week to reread PAS9980. I've not read it in full since it was draft. So actually going cover to cover was quite a good exercise for me. A couple of sections I think particularly useful for anyone who wants to learn a little bit more or thinks there's something in there that they haven't quite understood before. They want to go into a bit more detail. Section 6 of the document provides a good overview of the legislative context, so not just legislation as it stands now, but some of the history. Section 8, I think, is worth a read. It outlines the competence of external wall assessors. It's a very pertinent case put forward, and again, I agree with what's written in there. But again, good for anyone thinking about doing this work or thinking they've received a document and they want to see the competence of those doing it. And then 3 annexes I just think are quite useful for anyone that wants to learn a bit more. Annex A gives a good description of relevant fire tests. I actually give that to my students when I teach European fire testing. I just think it's quite a concise discussion on the different tests and how they correlate to national tests and things. So keep that one, it's a good one to read. Similarly, Annex L is quite a comprehensive description of wall types and materials. So I think it's a good one to be looking at for people going to site and certainly early careers. It's a good one to be just familiarising yourself or myself or whoever it is that's looking at this with some of the wall types we might see. And then for the methodology, obviously we've done the methodology quite quickly this evening because I'm limited again for time. I've run over already. But some worked examples in Annex O. So if you want to go through those three things and how the indicators work, there's some worked examples in the document. And that brings us to the end. So thank you for attending. There are hundreds of you, and we weren't expecting that. So good to speak to hundreds of people on a Wednesday evening. We run these every month, as I say, and they're all put online, so you can watch them back. If anybody wants to come deliver one, get in touch with us as well. I'm the Vice President of the branch. Get in touch with Dean, who is the President, or any of us on the committee. We'll be happy to facilitate. And if you want to talk to me about anything I've done or anything I'm working on, my contact details are on there as well. So, Dana, I'll hand back to you. Apologies, I have run over by a few minutes. Maybe time for a couple of questions. If not, I'll take some via email after.
That's okay.
So Dana, back to you.
Questions. Andy, I can see a hand up. If you can put that question in the chat for me, please, because I won't be able to dig through for hands up. In terms of extra reading and training for fire risk assessors, is there any way you would direct them so that they have a better understanding of when to go for an FRAEW and when not to?
Certainly read the Fire Safety Act 2021. That's definitely an important one to read. But also reading PAS9980 itself. I mean, when I put in there, when do we need one? A really good question is, when do you not need one? So I think reading PAS9980 itself is good. And that's what I've tried to do in this presentation, to just give a bit of, not necessarily we can all run off and do these assessments now, but an understanding of what it is and the methodology and when it would apply. So if someone came to me and said, I'm a risk assessor, I want to know a bit more, I'd certainly say, get on top of the regulatory stuff, stick your nose in the Fire Safety Act, and also have a read of PAS9980. It's free to download. So, read the introductory sections are, quite useful reading, and the ones I've suggested just there.
Brilliant, thank you. You mentioned a paper on the size of the building. Is that a paper that you could share?
Yeah, somebody sent it to me recently, so I haven't seen it for years. But it was published by me, and it's called "Does Size Really Matter?" And I'll dig it out and republish it with a better name, maybe. I'll think of a better pun and get it out there. But yes, whoever asks if they want to forward on, and I'll send it to them individually. No problem at all.
Thank you. I've had a few questions more about neutral ratings, and I know that we spoke about the presentation being more about the methodology rather than actually doing it. So I don't know if these questions, you might say, merge too in depth onto actually doing it. So a couple are, if you're getting repetitive neutral factors, how would the ratings be moved along the scale?
Well, the answer is it wouldn't shift to the scale too much. When you look at that scale, you have to assign a baseline to begin with. So in the example I showed, it was at the very low end, which is why I said it's likely to be an existing non-compliance or likely to be something with high risk. So if you continue to get neutral and you have things just that you would expect to see, you essentially don't shift that baseline. You remain where you are. So if you don't have an overwhelming number of positive factors nor an overwhelming number of negative, you just stay at that baseline. That's the simple answer. So if it's high risk and you don't have sufficient positive mitigation, it stays as high risk. If it's low risk, but you don't see anything overall negative, thank you, Howard. I'll send it to you with the pun rather than without. There's nothing overwhelmingly negative. It won't shift you away from that low. So you're not imposing risk by doing the assessment is the point. So the answer to the question, whoever it was that asked, or the few people, is you remain at the baseline. A lot of people after this paper, does size really matter?
Yeah, it's taken my attention. Not only that, you mentioned as well, I did actually keep wanting to correct you that it's PAS9980.
Yeah, every email I get tonight with people telling me how they pronounce it. I look forward to 400 emails of that. So yeah.
So one more on neutral factors. So when you say the thing we'd normally expect, does this refer to historic standards such as CP3 or the most recent ADB?
That is a really, really good question, actually. I think when we look at it, we have to look at the building as it would be intended to be constructed, but then take an objective view as to whether that would be suitable. So, for example, if we have a building that was constructed in 1896 and there was no meaningful kind of design guidance, we would, if we were just doing a compliance check, we would say, everyone wants the paper. I love it. Brilliant. I'll send it, Rich. No worries. And Laura, crikey. Okay. I'll and Emma. Jesus. Wow. Yeah. So if we have no discernible fire safety requirements at the time of building, we wouldn't then continue to say that's acceptable. We would have to infer that we've got a modern requirement. But a building that was designed in 2001, we wouldn't necessarily review to the 2022 standard of ADB. We would perhaps look objectively at what was in place at the time, whether that was constructed and whether we're still happy with that being in place. PAS9980 and fire risk appraisal of external walls is specifically for existing buildings. So it's intentionally for buildings that were constructed prior to 2018, you could infer, because that's when the building amendment regs were.
Brilliant. If I can, because there are a few more questions and it's moving quite quickly, if you can put up your contact details again for me, Joe. And if there are any more specific questions, you're happy with people to get in contact with you to discuss the ask.
No problem. Let me put up just my final slide again, so you can see there. If anybody wants to, if anyone wants to get in touch, a couple of people I've seen have asked about when it goes online. There's a little bit of stuff we've got to do at the IFE to get it agreed, but then it will go on the Southern Branch website in the next couple of days, normally, Dana, I think, isn't it? Doesn't take a huge amount of time. So you can get them, but otherwise they're on screen there. If you want to get in touch, come to either the Delta email or UCLan. I monitor them both all the time. So yeah, feel free to get in touch. Apologies we didn't get a chance to get through all the questions. There are literally hundreds of you, which there aren't normally, and I've run over slightly. So there we are. There's my details.
Brilliant. Thanks for joining, everybody. Have a good evening.